Hello everyone and welcome to today's video. Today we're going to be starting chapter 4 and we're going to be going over congruent triangles. So the whole chapter is going to be over congruent triangles. Now we're actually going to be combining two lessons. So not that. Lesson 4.1 and 4.2. So we're putting those two sections together. And let's go ahead and get started. Now when we're classifying triangles, because we got to know what we're talking about, so names, there are two main ways to classify or label or name the triangles. Okay, the first one is by the angles, the second one is by the sides. Now as you're looking at these, you're probably very familiar with all of these words. But even still, please make sure you have the word and the example written in your notes. That way you can come back and reference it, because we're going to get into further detail. Now, angles. You have acute, right, obtuse, and equiangular. All of these are talking about the angles. Okay, acute is talking about all angles are, that's an angle symbol, less than 90. Okay, with a right angle, you have one right angle. With a right triangle, you have one right angle. With an obtuse triangle, you have one obtuse angle. So one angle is greater than 90 degrees. Now, the equiangular, let's break this down. Equi means equal. Angular means angles. So equal angles, meaning all three angles are the exact same measure, and that measure is 60 degrees. All of these are referring to the angles of the triangle. Now the sides, here you have your equilateral triangle, your isosceles triangle, and your scalene triangle. Okay, now these labels do not overlap, so don't confuse your angles with the sides. First off, we have equilateral. Again, break it down. Equi means equal, lateral means line, sides. Equal sides, so all three sides are equal. Okay, isosceles triangle says that two sides are congruent. Okay, which actually means that an equilateral triangle is just a really special isosceles triangle. Okay, because think about it. If an isosceles triangle just means two congruent sides, then technically the equilateral triangle fits that definition. It has three sides that are congruent. It doesn't just have at least two, it has three. So that's how those two relate. Now, scalene is all by itself. In more ways than one, it doesn't have any sides that are congruent. All sides are a different measure. Okay, so those are the different names and the different titles. Please make sure you have them in your notes. All right, now let's use these names. Before we use them, let me ask you a question. How many triangles are there in this picture? Take a moment to think. If you said 3, you are correct. All right, you've got the first triangle right here, the second triangle right here, and then the big triangle right there. That makes 3. So 3 big triangles, which means, 3 triangles, which means we are going to have 3 different classifications. Okay, so let's go over this. In this first one, I have my small triangle, triangle number 1, triangle number 2. In triangle number 1, I have 2 angles that are equal, which is lovely. But then I have this one right angle, so that means that triangle number 1 is a right triangle. Same with triangle number 2. It has also a right angle, so triangle number 2 is also right. Now this one up here, Q, 45 plus 59 is definitely greater than 90. Or than 90. So we got 104. So that means that triangle number 3, the really big one, is obtuse. Now if you're looking at these and you're thinking, wow, those are all angle names, you are correct. You also might have figured this out with the instructions. When you're doing these problems, make sure you are always reading the instructions. I know I say that a lot, but still, it's true. Read the instructions. If it says classify by the angles, you need to classify by the angles. If it says classify by the sides, you need to classify by the sides. So make sure you're giving the question what it asks for. Okay, now this one, we read instructions and we are labeling it by its sides. So here we go, instructions. Let M be the midpoint of JL. Midpoint means that the JL is cut into two equal pieces. So JL, this is congruent to this, which already has a congruency marking. So all of these are congruent to each other. Okay, now let's look at this. Here we go. We've got triangle number 1, 2, and the big one is 3. Now, let's look at my little one, number 1. I have 2 sets of congruent sides, so isosceles. I'm going to shorthand that as ISO. Okay, number 2 also has 2 sets of congruent sides, so it is also iso triangle. Now, number 3, we look over at the big one. There really isn't between this measure, this whole measure, and this measure. There isn't a set of congruent sides. And, well, that says a lot. That cancels out 2 of our options. So that means that number 3 is scalene. And there you have it. So pay attention to the individual triangles. Remember, there are 3 in this picture. If you got to label them like I did, go for it, but try to remember that there are 3 different triangles in this picture, and you need to label all of them. All right, here we go. I'm going to let you try these. The video is going to pause, and when it starts again, we'll go over the first one. Now, this first one is an isosceles triangle. I have 2 sets of congruent sides, so I know that they're going to be congruent. And that's where I'm going to go with this problem. I have 2 congruent sides, therefore the measures are equal. So 4x plus 1 is equal to 5x minus 0.5. And now it's algebra from here. So minus 4x plus 0.5. 1.5 is equal to x. Now again, make sure you're following instructions. The instructions say find the length of each side, not just find x. So let's go ahead and plug it in. I'm going to change colors so you can see what I'm doing. So we've got 4 times 1.5 plus 1. 4 times 1.5 ends up being 6 plus 1 is 7. Okay, let's go to the other side and see if we get the same answer. Now, because this is an isosceles triangle, it should come out to the same. So 5 times 1.5 minus 0.5. 5 times 1.5 is 7.5. So 7.5 minus a 0.5. It is indeed 7. All right, and then last but not least, 9 times 1.5 minus 1. This gives us 13.5 minus 1, which is 12.5. So those are your 3 side lengths. All right, go ahead, try the next one. When the video plays again, you'll see the answer. All right, and there we go. Now, if you read the instructions, you would have seen that the triangle is an equilateral triangle. This means that all the sides are equal, and therefore we can set 2 of them equal to each other and solve for the variable. Now, I picked 2y plus 5 and 3y minus 3 for no particular reason. I could have picked any of the others, but I just went with those because those were on top. Because they're congruent, you can set them equal to each other, and when you solve, you get that 8 is y. But again, just like in the last problem, we're trying to find the side lengths. So I plugged it in to the top equation. Now, since this is an equilateral triangle, I know that all of the sides will equal 21, and I technically don't have to solve for the rest. But if ever you doubt your number, a good way to check is to always plug it into a different equation and see, or a different one of the side equations, and see if you get the right answer. All right, so now what would this class be without proofs? So the triangle angle sum theorem, we're going to prove this. If you don't know what the triangle angle sum theorem is, don't worry. We'll get to it on the next slide. So we are given that XZ is parallel to AY. This is given to us, and we are trying to prove the measure of angle 1 plus measure of angle 2 plus measure of angle 3 are all equal to 180. All right, well, this is interesting. Let's look at this. So first off, I know that ZX, here, let me change color so you can see what I'm doing. We'll go with blue. All right, I know that ZX is parallel to AY. All right, and because these lines are parallel, I know that 4 is congruent to 2. So 4 is congruent to 2 because of the alternate interior angles theorem. So angle 4 congruent to angle 2. For the same reason, I know that angle 5 is congruent to angle 3. Again, the alternate interior angles theorem. But somehow, I need to get this equation of 180 in the mix in here, somewhere. And as I look at this, I see that angles 4 and angle 1 and angle 5 all make up that line of AY. Which means I could say the measure of angle 4 plus the measure of angle 5 plus the measure of angle 1 all adds up to equal 180. Now, why does it equal 180? Because the measure of AY is 80, or 180. So that's what we're going for. So first off, I'm going to say that the measure of AY is equal to 180. Why do I know this? Definition of a straight angle. Oops, spelling. Let me fix that real fast. Nope, okay. So, straight angles. If ever I don't erase again in this video, that's why. All right, definition of straight angles. Now, I can say the measure of angle 1 plus the measure of angle 4 plus the measure of angle 5 is equal to 1, or is equal to AY. And this is because of the angle addition postulate. Haven't used that one in a while. Now, when you're writing this equation, please make sure that you're being very careful and lining up the measure of 1, the measure of 4, the measure of 5. Otherwise, you're going to have to scramble things around later in your problem. Now, I know that AY is equal to 180, so I can plug that in. Measure of 1 plus measure of 4 plus measure of 5, angle 5, is equal to 180. And I know this because of the substitution. It fits right in there. Everything is equal signs so far, so we're good. All right, and now I'm going to say my alternate interior angles. I'm going to say that angle 4 is congruent to angle 2, and that angle 5 is congruent to angle 3. And I know this because of the alternate interior angles theorem. Now, these are congruency symbols, so I got to turn them into equal signs. So the measure of angle 4 is equal to the measure of angle 2, and the measure of angle 5 is equal to the measure of angle 3, by the definition of congruency. Last but not least, it's a simple matter of substitution. Now, this is why I said earlier you need to be careful on your order, because we need measure of angle 1 plus measure of angle 2 plus measure of angle 3. 4, we're going to replace that with the measure of angle 2, and measure of angle 5 will be replaced with the measure of angle 3, which is the exact order that we want. So hopefully you were careful there. Otherwise, you're going to have to add a step and rearrange. Otherwise, I have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 by substitution. And that's it. So this proof is actually a really good example of how prior information is going to come back. We used about 3 things that are big in other chapters, and that we haven't really used outside of the chapter before. Definition of straight angle. That hasn't come back since chapter 1, but here it is. Same thing with angle addition postulate. All right, and then alternate interior angles was last chapter. So we got a lot of really big things that are coming back and being put all together. So make sure the things to remember are your angle addition and segment addition postulates, and then all of your parallel line theorems. All of them. They don't go away. So make sure you have those memorized and in your memory to use. Now, the reason we went through all of this effort to prove that angle 1 plus angle 2, or the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180, is to prove the triangle angle sum theorem. For those of you who still haven't figured out what that is, no worries. Here's the definition. The triangle angle sum theorem states the measure of the interior angles of a triangle add up to 180. And there it is. Now, I hear a lot of you yelling through the camera that, Miss Stockton, we already knew that. Well, yes, you already did know that, but here's why you know that. Remember, geometry is all about proving why we know things. So why did you know? How did you know the measure of the interior angles of a triangle was 180? Well, it's not just because you were told, although I'm sure you were, but it's also because you could prove it. And so we did. We proved it using alternate interior angles theorems and angle addition postulate and several other things. Okay? Keep in mind, this chapter we are proving stuff. All right? So that being said, let's talk about some other things. Now, corollaries. Now, corollaries are statements that follow immediately after you've proven a theorem. So theorems need to be proven. But once they're proven, there are some things that logically just happen. They're logical conclusions. All right? Kind of like extra things that you can conclude. Now, corollary number 2 is that each angle in an equilateral triangle has a measure of 60. Okay, let's think about this for a second. Equiangular, equal angles. By definition, if an equiangular triangle has 3 equal angles, and all 3 of those angles have to add up to 180, then it just logically follows that they have to be 60. The measure of each angle is 60. Okay, so that's an example of a corollary. The next one, there can be at most one right or obtuse triangle, a right or obtuse angle in a triangle. And last but not least, the acute angles of a right triangle are complementary. Okay, that makes sense because think about it. If you've got a right triangle, you've already got 90 degrees taken up. So the measure of angle 1 plus the measure of angle 2 has to add up to 90. Otherwise, the sum wouldn't be 180. So these are 3 examples of corollaries. And now that we have proven the triangle angle sum theorem, you are allowed to use these in your math and in your proofs. You're welcome. I know this excites you. I can hear your enthusiasm through the camera. Let's continue this excitement. Now, this one you probably aren't aware of. So here's new information. The third angle theorem. This one states that if 2 angles in one triangle are congruent to 2 angles of another triangle, then the third angles of each triangle have to be congruent to each other. Okay, let's play with some numbers for a minute, and this might make more sense. Let's say my green angle was, I don't know, let's make life easy and go 40. That means this green angle is 40. Okay, then my purple angle is 50. Which means this purple angle is 50. Now, by using the triangle sum theorem, 40 plus 50 is 90. My red angle has to be 90. Which means that this other red angle over here also has to be 90. Okay? So if you have 2 angles in 2 triangles that are congruent to each other, then necessarily that third one must also be congruent to each other. This one is called corollary 1. And we're going to use this a lot. But for right now, let's keep going. Here we go. Proof number 2. So here we go. We are told that PQR is a triangle. Why is that important, you ask? Well, because we can now use our newfound theorem, the triangle angle sum theorem. So keep that one in mind. We're trying to prove that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. Interesting. Okay, so let's do this. So triangle PQR, this is given. And as I said a moment ago, we just learned the triangle angle sum theorem. Please be careful with your symbols. Make sure I can read them. So let's go ahead and use it. I know that the measure of angle 1 plus the measure of angle 2 is going to be, plus the measure of angle 3 is equal to 180. All right, this is my triangle angle sum theorem. But let's look at the triangle again and see what else I know. I need to somehow get angle 4 in here. Well, here's angle 4, and I see that it is a linear pair with angle 3. So let's write that. Measure of angle 3 plus measure of angle 4 is equal to 180 by the definition of linear pairs. Okay? Now I have two expressions equal to 180, so I'm going to go ahead and put them together. It's going to be a really long one. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. I just put them all together because both expressions were equal to 180. I can do this because of substitution. Now, you can kind of see where I'm going with this. I have on one side measure of angle 2 plus measure of angle 1. And I have measure of angle 4 on the other side. I do have this pesky, iPad malfunction, measure of angle 3 in the way. So I have to subtract that out. But before I can do it, since it appears in two different equations, measure of angle 3 is equal to the measure of angle 3. Okay, now that we have said those two angle 3's are equal to each other, I can subtract them and say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4 by subtraction. And we're done. It matches exactly. So this is how you would use the triangle angle sum theorem. All right, you can use it in a few other ways, but whenever the proof kind of wants you to use it, a hint they'll give is by telling you it's a triangle. Now, this proof, what we did right here, is we proved a theorem. This theorem is called the exterior angle theorem. What this one states is that the measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. Now, I underlined vocab word that might be iffy. Exterior means outside. Okay, so an exterior angle is an extension of one side of the figure. Okay, so PQ extends into PS, and that means that angle 4 is our exterior angle. If I was going to extend QR like this, angle 5 would be an exterior angle. Okay, if I were to extend PR again in the other direction, then angle 6 would be the exterior angle. Okay? Now, the reason why it has to be an extension of a side is because, think back to our proof. We said that the exterior angle and the interior angles were linear pairs. So that's a good way you can double check and make sure you're really dealing with an exterior angle, is that if it's a linear pair to one of the angles inside the triangle. Now, this other word, remote. Okay, remote means far from. So let me change colors so you can see what I'm doing. If we're looking at angle 4, then angle 3 is right next to it. But angle 1 and angle 2 don't even come into contact with it. They are far away. They are remote. Okay, think of a remote island. A remote island is out in the middle of the ocean. There's nothing by it. Angles 1 and angle 2 are remote to angle 4. They're far away from it. Okay, and this is the exterior angle theorem. This one gets used a lot. Sometimes it gets tricky though, especially when we start adding triangles together and there's a lot of triangles in one picture. So really make sure you're paying attention to which angles could be an exterior angle. Let's do a problem. So in this first one, we have angle X is our exterior angle, and we're given 55 and 45. So right away, we know that X is going to be equal to 55 plus 45, which means that X is equal to 100. All right, you guys give the next one a try. The video is going to pause. You'll see my equation, just the general setup. It's going to pause again, and then you'll see my answer. Go for it. All right, here's the equation. Let's keep going. And there you have it. X is equal to 56. All right, guys, that's all for the video for today. If you have any questions, let me know, and I'll see you next time. Bye.